Let's talk about the chain rule and get a lot of practice with it. So I believe in a previous example, I go into more detail of what the chain rule actually is. Let's just review it real quick. If we have x mapping to y values underneath some function g, and those y values mapping to another variable z underneath a function f, then this is the function f of g of x. This is how I get my z values. So if I differentiate z with respect to x, so I want to study how z changes as the variable x changes, I can differentiate z with respect to y. So I can differentiate the f function first, and then I can multiply by the derivative of y with respect to x. So I can multiply by the derivative of that function, g function first, and then. So effectively, I can just connect the z variable to the x variable by passing through the y variable. And I can do this for a multitude of variables. Here we have a variable t that maps to a variable u, which maps to a variable w, which finally maps to a variable y. So we can differentiate y with respect to t, so I can connect this variable to that variable by multiplying by the derivative of y with respect to w, and then the derivative of w with respect to u, and finally the derivative of u with respect to t. So in short, the derivative you just differentiate the outside function first. So I'm going to differentiate the f function, and I'm going to differentiate it with respect to what's on its inside, which is the g of x function. And then I'm going to multiply by the derivative of the g of x function with respect to x, because that's what's on the inside of the g function. All right, the best way to get good at this is to practice. Let's find the derivative of f of x with respect to x. So I can view this as a function inside of another function. So first, let's differentiate the outside function first. We've got something being cubed. So how do we differentiate that? We bring the 3 down, we have that something, and now the new power is a 2, because 3 minus 1 is 2. That's the power rule. But now we're not done, because we didn't differentiate it with respect to x. We differentiated it with respect to what's on the inside of the cubic function, square root of x. So now we need to differentiate the square root of x with respect to x. And if I'm not ready to do this at this stage, I'll just write down derivative with respect to x of the square root of x. And we can simplify with a little bit of algebra. So square root of x squared is just x. And the derivative of the square root of x with respect to x is 1/2 x to the minus 1/2 by the power rule. And cleaning this up with a little bit of algebra, we got 3/2 square root of x. Now, we could have also gotten here by simplifying so that we didn't have to use the chain rule. This is just equal to x to the 3/2. So if I differentiated this, so I don't want to say it's equal to, but if I differentiate this, so underneath the differentiation map, this x to the 3/2 becomes x to the 3, x to the, sorry, 3/2 x to the 1/2. So you got the same thing. All right, let's keep going. This time a little bit faster. If I wanted to differentiate this function, I've got something to the minus 3. So the derivative will be minus 3, that something, now to the minus 4. We will then multiply by the derivative of that something. So by 10x to the 4th plus a 1. Here we have something cubed. So the derivative will be 3 times that something squared. And now multiplied by the derivative of that something, 1 minus 2t. So, oh, there's one more. All right, here we have something squared. So this will be 2 times the something it now has a new power of 1, multiplied by the derivative of that something. That something is something being cubed. So we have 3 times 2s to the 7 minus 4s, now squared, and then multiplied by the derivative. Let me put my multiplication symbol there. And then multiplied by the derivative of that thing that was being cubed. 14s to the 6th minus a4. So every time you use the chain rule and you differentiate the outside layer of the function, you leave the inside layer alone, and then you just multiply by the derivative of the thing that you've ignored.